A Chapter 4 topic this time, balancing chemical equations. It's a relatively straightforward process, but there are a few questions that are more challenging than others. And I kind of like this one. It involves nitroglycerin, a famous explosive chemical compound, and it simply just balances the reaction that occurs when it explodes. So as we often do, here's the text of the question itself. Now, they tell us what we need to do is simply take this thing and write the chemical equation and then balance it. This one's a bit more of a challenge than some of the Mastering Chemistry or end of chapter questions. So here we go. Let's start tackling this thing. Now, they do give us the formula for nitroglycerin. They tell us that it's C3H5N3O9. And then they tell us that when it explodes, it breaks down, it decomposes into carbon dioxide, water, nitrogen, and oxygen, all of them in the gas phase, makes 4 gases. Now, they don't give us the formulas for those products, but, you know, my goodness, if we don't know these formulas by now, we really ought to just drop the class. So, carbon dioxide and water and nitrogen and oxygen, all in the gas phase. Okay, so there is the basic equation. Now, it's not balanced yet, but there are all the formulas in place. So we've made sure the formulas are correct, and now we remember we cannot change any of those subscripts. Those are now fixed. All we can do is change the coefficients, the numbers we're going to write out front. Now, we have 4 atoms to deal with: carbon, hydrogen, nitrogen, oxygen. Of the 4, nitrogen or oxygen is going to be the tough one to look at because it appears the most often, so we save that one for last. So I'm going to begin with the carbons, okay? And I look at the molecules here. I've got 3 carbon atoms on my reactant side, 1 carbon on the product side. That's pretty easy to solve. I need 3 CO2s. And I'm even going to keep a bit of a chart here on number of carbons. I have 3 here. I now have 3 on this side. So that's looking good. Now, I know I've changed the number of oxygens as well, but I don't worry about that. I'm taking the atoms one at a time. Carbons taken care of. Now, I move my attention off to the hydrogens. 5 of them on the left, 2 on the right. An odd number, an even number, so yes, we are going to have to adjust both coefficients. We're going to use the smallest, the smallest number they have in common, 2 and 5, and that's going to be 10. So if I use 5 here, and make sure it comes out a good 5, 10, I've got 10 hydrogens on this side. So that means I'm going to need 2. Notice how I use the numbers. The 5 is over here, the 2 is over there. I have 10 hydrogens as well. That makes that work out, but yes, I have already dealt with the carbons, and now I've changed one of those coefficients. The number of carbons is now, it's nice to have a board here, we can do that, is 6. So I had better go back and fix the carbons. It's going to be pretty easy to do. There. Clue. If you're working on these out on paper or something like that, it's really a good idea to have a pencil or something. People try to do these in pen, and boy, does it look messy after a while. So now I've done my carbons, I've done my hydrogens, and yes, I've got 6 of those, so that's all good. Nitrogens. Now, the nitrogens, 3 in the molecule. Now I have 2 of those molecules, so I have a total of 6 on this side. I look over here, they come in packages of 2. I'm going to need 3 of these molecules. 3 times 2 gives me 6. And the nitrogens worked out. So carbons are good, hydrogens good, nitrogens are good. This is where you bow toward the gods of chemistry. Oh, please let the oxygens work out. And we are now going to examine those oxygens and make whatever adjustments we need to make. I have 9 per molecule, 2 of them here. And so I have 18 on this side. Over here with all those different things, I've got 12 oxygens there, plus 5 oxygens there, plus 2 more. 12, 30, 40, 50, 60, 17, 18, 19. 16, 18, 19. Well, that kind of didn't work out so well. Now, there's a couple of ways, a couple of things, there's a couple of choices here. You can, cuss it out and leave, one possibility. You could try something like this. Oh, look, puppies. There. And, oh, look, oh, silly me, there's only one. Now it's 18, 1 and 18. Now it's nice and balanced. But hopefully, if you try to pull something like this, that, suddenly a voice will speak from above.
Marcus, you moron. You just screwed around with one of the subscripts.
And it is true. I have messed with the subscripts. And that I am not allowed to do. Darn it all. So I've got to put that subscript back. Not allowed to change them. I don't have 18. I've got 19 of these things. Darn. So the alternative is to adjust the coefficients again. And what I'm going to do is you've seen us in class do this a couple of times. What if I just put a fraction in right there? Put a 1/2. Now that would work because that just gets me a 1 right here. Now, I'm not going to leave that fraction there for a long period of time, but it is legal to put it in there, at least for the moment, simply because it is a coefficient. Those you are allowed to change. You're not changing the subscripts. But to get rid of the fraction, because one interpretation is I've made 1/2 mole of oxygen, that's reasonable. But the other interpretation is I made 1/2 molecule of oxygen. That's not reasonable. And so we often want to write our equations with nice, pretty whole numbers instead. And so to clear that fraction, it's a fairly simple thing. I just simply double all of my coefficients. And that gets me nice, pretty whole numbers. Okay? And so that's going to get me 4 C3H5N3O9 produces 12 carbon dioxide molecules, 10 water molecules, 6 nitrogen molecules, and 1 oxygen molecule. Now, I go through and I check my balancing once again. With something complicated like this, it's always a good idea just to make sure everything worked out. 4 times 3, 12 carbons, 12 carbons, yes. 5 times 4, 20 hydrogens, 10 times 2, 20 hydrogens, yes. 4 times 3 is 12 nitrogens, 6 times 2 is 12 nitrogens, yes. Okay, oxygens, here we go. These are the big ones. 9 times 4, 36 oxygens on the reactant side. 12, 2, 24 oxygens, plus 10 oxygens, plus 2 more, 24, 34, 35, 36. Oh, man, the oxygens are balanced, everything's balanced. It's a beautiful thing. There, balanced chemical equation. Remember, never adjust the subscripts. You're only allowed to play with the coefficients. Okay? So keep that in mind. Practice a few on your own, and talk to you later.